Hello everyone! I am Simon Malikdem and all of you are now in the segment of Excel in Management Science. Yes, Management Science. And I would be demonstrating on how to forecast with the help of our little friend Microsoft Excel. We're going to forecast by moving averages and exponential smoothing. Hawkins Company has come to me and they said that they have something on forecasting. They need a little help on forecasting. So here I am going to help them on forecasting. For the Hawkins Company, the monthly percentages of all shipments received on time over the past 12 months are 80, 82, 84, and so on. Compare a 3-month moving average forecast with an exponential smoothing forecast for alpha, which is 0.2. What is the forecast for the 13th month? So I prepared 2 set of tables here, which is for the moving average and the exponential smoothing. For the 3-month moving average forecast, we have our months 1 to 12, the time series value 80% for the first month, and so on. And now we're going to solve for the forecast using moving averages. So when we are going to solve for the moving average, we're going to utilize data analysis. So go to data tab. Here is data tab. Go to data analysis. Find moving average. This is moving average. Click OK. Input range, you're going to put the time series value for the first month to the 12th month. For the interval, we're going to put 3 since this is a 3-month moving average. For the output range, we're going to start with the second month, not the first month. Why not the first month? I would be showing to you the output when we start for first month. Okay. So first to 12. Click OK. As you can see, there are only 2 intervals, which is already wrong because our goal is to have 3 intervals. So when we have the average of the first, second, and third month, we expect to have a forecast in the 4th month. So this is wrong. 82 is the average of the first, second, and third month, which should be the 4th month's forecast. So let's delete this. Go to data once again. Data analysis. Moving average. Input range. Interval 3. Output range, we're going to start with the second month. Okay. Click OK. So there we have it. We have 1, 2, 3 intervals. And we also have the 13th month forecast, which is 83.33. Okay? So we have our forecast using moving averages. So for the forecast error, we would only subtract 83 and 82. Enter. So we have 1. Drag the corner until the 12th month. And there we have it, our forecast errors. Next, we need to solve for the absolute value of forecast errors. Okay, so the formula would be equals ABS for absolute value, open parenthesis, 1, close parenthesis, and click enter. So, drag the corner to the 12th month, and there we have it, the absolute value of forecast error. Next is the squared forecast error. Equals, type in power, open parenthesis, click 1, comma, and type in 2 since this is squared forecast error. So we need to type 2. Okay? Click enter. Drag the corners to the 12th month. And there we have it, our squared forecast error. Next is the absolute value of percentage error. We're going to type equal, open parenthesis, type in the absolute value of forecast error. Just click the cell, divided by the time series value, close parenthesis, and multiply it by 100 since this is a percentage. Click enter. So drag the corner to the 12th month. So there we have it, our absolute value of percentage error. To get the total or the sum of each column, select all of these, and click auto sum. There we have it, the summation of absolute value of forecast error, squared forecast error, and absolute value of percentage error. So, let's solve for the mean of the 3 columns. For mean absolute error, divide the total with the number of forecasts. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So equals 7.33 divided by 9. Enter. So this is our mean absolute error. For squared forecast error equals 11.11 divided by 9. This is the mean squared error. Mean absolute percentage error equals 8.80 divided by 9. To make it 2 decimal places, rounded up to 2 decimal places, let's decrease the decimal. So, there we have it. Our mean absolute error, mean squared error, and mean absolute percentage error. Next, let's proceed to the exponential smoothing forecast. Here are the months 1 to 12. Time series value, same as the 3-month moving average forecast. For the forecast, let's go to the data tab again. Data analysis. Find exponential smoothing. So here's exponential smoothing and click OK. Input range is the time series value. Damping factor. Damping factor is 1 minus alpha. In this case, our alpha is 0.2. So 1 minus 0.2 is 0.8. Let's type in 0.8. Output range, unlike the moving averages, we would be starting in the first month. Okay? Click OK. So there we have it. We don't have the forecast for the first month. We will be starting in the second month. Okay? So to decrease the decimal, go to Home and click Decrease Decimal. Okay. For the forecast error, subtract 82 and 80. Drag the corner to the 12th month. And there we have it. Absolute value of forecast error equals ABS, open parenthesis, 2, close. Click Enter. Drag the corners to the 12th month. Okay? So, next squared forecast error, which is the power, equals power, open parenthesis, 2, with the power of 2. Click Enter. Drag the corner to the 12th month. Okay. Absolute value of percentage error equals, open parenthesis, the absolute value of forecast error, which is 2, divided by time series value, close, times 100. Click Enter. Drag the corner to the 12th month. And there we have it. We would be only adding each column by AutoSum. Select the 3 columns and click AutoSum. Okay, so next, let's solve the mean absolute error. Equals the total, which is 17.59, divided by how many number of errors? Oh, number of forecasts? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 forecasts divided by 11. So next is the mean squared error, equals 39.11 divided by 11. There. Next equals 21.05 divided by 11. There. Then we can decrease the decimal. And there we have it. The missing forecast for 13th, we can solve it by equals open parenthesis 83 times 0.2 plus the
damping
factor, which is 0.8. So 1 minus 0.2 is 0.8 times the forecast for the 12th month. And click enter. Okay? There we have it. We're done with the instructions gave by Hawkins Company. If we compare the mean absolute error, mean squared error, and mean absolute percentage error of the moving average forecast and the exponential smoothing forecast, we can see that the moving average has a mean that is lower than the exponential smoothing, which means that moving average has a better forecasting accuracy compared to exponential smoothing. So there we have it. We already helped Hawkins Company with their problem. I am Simon Malikdem, and please wait for me to release more content regarding Excel in Time Management Science. Thank you very much!